Today's lesson objective is 4.4H. Solve with fluency 1 and 2-step problems involving multiplication and division, including interpreting remainders. Let's begin by looking at some 2-digit by 2-digit multiplication. So here we have a problem that says Raymond purchased advertising for his store in the local newspaper. If the advertisement cost $89 per day and Raymond ran the advertisement for 45 days, how much money did Raymond spend on the newspaper advertisement? Okay, so our clue here was the per day and how many days. So we are going to have to multiply that cost times the number of days, so 89 times 45. Now, using our standard algorithm, which basically means our steps for multiplying, we begin here with the 5 in the ones place, and we're going to multiply 5 times 9 to get 45. So we'll bring down the 5, carry the 4. And then we're going to do 5 times 8, which is 40. Add the 4 that we carried, and so that gives us 44. Now, the 0 for the placeholder comes down because of our place value changing. We're now going to multiply by the 4, which is in the tens place. So we're going to do 4 times 9, which is going to give us 36. So we're going to bring our 6 down, carry our 3. And then we're going to do 4 times 8, which is going to give us 32 plus 3 more will make 35. Once we finish multiplying our digits, we are going to add our totals together. So we're going to have 5 and 0 give us 5, 4 and 6 is 10, so 0 carry our 1. Okay, then again 1 and 4 is 5, another 5 makes 10, so we get 0 carry our 1, and then we add 1 and 3 and we get our 4. So $89 times 45 days is equal to $4,005. So that's what Raymond spent on his advertisement. Okay, here's one more example of multiplication. In this example, we're doing a 4-digit by 1-digit. Okay, similar scenario here. We got Raymond owns a television store. He ordered 4 different televisions for floor models. Each television with tax will cost him $1,689. So the question is, how much money did Raymond pay for the 4 televisions? So again, here our clue was each. So each one costs this amount, and we are buying 4 of those. So this is a multiplication problem. Okay, so here we have 1,689 times 4. So we're just going to start with multiplying 4 times 9, which will give us 36. Carry our 3. 4 times 8, which is 32, plus our 3 makes 35. So we'll bring down our 5, carry our 3 again. 4 times 6 is 24, plus 3 will give us 27. We'll bring down the 7, carry our 2, and then we'll do 4 times 1, which is 4, plus 2 more gives us 6. And so we figure out that the 4 televisions will cost Raymond a total of $6,756. Okay? Another way you might have looked at this problem is, since we're multiplying by 4, that's 4 televisions, right? That's the same thing as we could have doubled what it costs for 1 TV to find out what it costs for 2 TVs. And then double that amount again to find out what it costs for 4 TVs. So this one could have actually been done without multiplication if we're really good at doubling numbers. Okay, so that's just a kind of an alternate way you could have worked this problem. Alright, so now let's talk about division. Okay, in this example we're going to do a 3-digit divided by a 1-digit. So here the problem reads, Tex spent a total of $852 on 6 television stands. So the question is, how much did each television stand cost? So we know the total, and we know how many was purchased. So from that, we should be able to figure out how much each one was using division. So here we're dividing 6 into 852. So we begin by dividing 6 into 8. We know 6 can only go into 8 one time. So we do 6 times 1 gives us 6. And then we're going to subtract that. Okay, so we're going to subtract the 8 and 6. Now you may be wondering where these zeros are coming from. Okay, well remember this 8 was really in the hundreds place, right? And as far as our place value is concerned, so the 8 really represents 800. So really we're saying how many times would 6 go into 800? And so we're saying it's going to go in there 100 times. That's what that's really showing, okay, because of where the place value lies. So in reality we're actually doing 600 from 852. Okay, but you may learn that as just 8 minus 6, which is 2, and then you bring down what's left. Okay, either way is fine, whichever way you're more comfortable with. Again, this one's just using the place value. So after we remove the 600, that leaves us with 252 left. So now the question is, how many times can 6 go into 252? Okay, so we'd say 6 can go in there 40 times. So that's what this is showing. Okay, again, using the standard algorithm, you would have just said, all right, well, 6 goes into 25 4 times, and you would have put the 4 there to say 6 times 4 is 24. Okay, but using the place value, it's really 6 times 40, which is 240. Now again, we subtract those. Using the standard algorithm, you would just subtracted this and got the 1, brought down your 2. Using the place value method, which is what this is, we're actually going to subtract 240 from 252, which leaves us with 12 left. Okay, and then our final would be, how many times will 6 go into 12? So that goes in there twice. This is in the ones place, so that 2 actually does represent just the number 2. And so 6 times 2 is 12. So we take away 12, there's nothing left. So in this problem, we know that 6 divides into 852 142 times. Okay, so each television stand costs that much. Alright, let's do one more division problem here. We're going to do a 4-digit divided by 1 digit. So this one, Tex spent $2,574 on a television. He is able to split the cost over 6 equal monthly payments. So what is the price of each payment? So again, we're dividing this total into 6 equal sized payments to figure out what one payment costs. Right, and so again, this time they're using that place value method. So this is not really your standard algorithm, but this works. This is just a different way of looking at it. So we're looking at place value. So the question is, how many times would 6 go into 2,574? Well, the closest we can get is 400 times, because 6 times 400 is 2,400. Okay. Now, using standard algorithm, you would have said, okay, well, 6 can't go into 2, so how many times will 6 go into 25? And that would have told you, oh, it's 4 times. Okay, but again, based on the place value, that's really 400, not just 4. Okay, because it's in the hundreds place here. All right, so you subtract the 2,400 from the 2,574, telling you still have 174 left to go. Okay, so and again, using standard algorithm, you subtracted 24 from 25, got 1, you brought down the 7. All right, same idea. So now it's how many times would 6 go into this? Okay, so using the standard algorithm, you would have said, okay, how many times does 6 go into 17? All right, but using the place value method, how many times will 6 go into 174? Well, we know that that's going to be 2 times, or in reality, that's actually 20 based on its place value. So 6 goes into 174 20 times. Okay, so 6 times 20 is 120. Using the standard algorithm, you would have said 6 times 2 is 12. You would have subtracted. Either way, you end up with getting a 5 here and bringing down the 4. So you got 54 remaining. So then the final question is, how many times will 6 go into 54? It goes in there 9 times. This time the 9's in the ones place, so it's really worth 9. So 6 times 9 is 54. And so you take away, and that leaves you with no remainder. So it leaves you with nothing left over. So this is going to tell you each payment will be a cost of $429, okay, for that television. All right. Okay. So we're going to look at a few more problems. Now, in these examples, we're not going to show working it out, okay, but we are going to talk about what each of these types of examples represent. So these are actually division problems. This first one is an example of what we call ignoring the remainder. Because sometimes when you do division, you don't get a nice perfect answer like we did in our last 2 examples. Sometimes there is something left over, and whatever is left over, that's what we call the remainder. Okay, so based on our word problem, we have to decide what importance that remainder has. Okay, so let's look at this example. It says, if a box of 1,750 toothpicks were distributed to 8 students in the class, how many toothpicks would each student receive? Well, when you divide 1,750 by 8, you get 218 with 6 remaining toothpicks left over. So each of the 8 students would receive 218 toothpicks apiece, but you would still have these 6 leftover toothpicks, which is not enough to give each student another toothpick. So in that case, you would just discard those 6 extras so that everybody could have the same amount. So we wouldn't keep the remainder in that example. We'd stop at 218. All right, this one's called add 1 to the quotient. Okay, so let's see what they're talking about. It says how many vans are needed to transport 231 people if each van can only hold 8 people. So again, we divide 231 by 8. This time we get an answer of 28 with a remainder of 7. So what that means is that answer is telling us that we could fill up 28 of these vans with 8 people each, and there'd still be an extra 7 people left over. Well, those guys want to go too, right? You can't just leave them there. So you're going to need 1 extra van to carry those 7 extra people. So in reality, you'd want to purchase 29 vans so that you can fit everybody. Okay, so that's rounding up to the next number. Okay, this one's called remainder is the answer. So in this example, it says pencils come in boxes of 24. If a teacher had 13 boxes to share among her 5 classes, how many pencils would be left? Okay, so this is actually a 2-step problem. We're actually going to start by finding out just how many pencils there really are. So 24 pencils come to a box, and there's 13 boxes. First we multiply 24 times 13, and we get an answer of 312. So there's a total of 312 pencils. Now, we want to share those equally amongst the 5 classes, so we're going to divide that by 5. When I divide 312 by 5, I get 62 pencils go to each class, with the remainder of 2 leftover pencils. So the question says how many pencils would be left over after you distributed them equally amongst the 5 classes. So in this problem, the answer is the remainder. There would be 2 leftover pencils at the end. Okay, so this one, the remainder, is the answer. All right, so this concludes our discussion of multiplying and dividing. Thank you for your time.